Hello and welcome back. This is Barrett from the C4 Cyber Club here at Cypress College. And in this lab, we will cover the Ethical Hacking Lab series, Packet Crafting with Scapy. So essentially, Scapy is an interactive packet manipulation tool. And when I say packet manipulation, you can also think of it in a malicious sense to where this can be used also to forge packets. It could also be used for just a general packet generator, network scanner, network discovery, and a packet sniffer. So we could see this kind of being a replacement tool at times for things like Nmap and hping and other command line packet sniffers like TCP dump and tshark, which is a command line version of Wireshark. And we will actually use Wireshark a little bit as we create some packets in here and start sending those off. So essentially, Scapy uses a Python interpreter as a command board. So you'll notice that some of the commands, they might be a little bit different, a different feel for you. But essentially, this means that you can use direct Python language in this as well, like assigning variables, using loops, and defining functions. So there's a lot of power behind it, especially if you are familiar with Python as well. And essentially, what Scapy does is it sends packets and receives answers. So you define the set of packets, it sends them off, and then you receive the answers, and then you could take a look at that. So we will just dive right on into it and do some examples of generating a particular packet and setting certain fields. Okay, so we will be using the Kali machine pretty much exclusively in this lab. And so from the terminal, we just type in Scapy. And this essentially launches us into, like I said, that Python interpreter command board. So we could list out all of the protocols and layers that are available, which are a lot. So if you scroll up, you see these are all of the different options of different protocols and various layers of packets that we can manipulate. Okay. Now we can also list out available commands. So LSC. So these are various commands that we could use. And now we could just jump into building a packet, right? So if you look at this image, this is, if you have taken CIS 230 Cisco networking class, you will be familiar with IP headers and all of the different fields. Source, destination, address, obviously, two of the most important fields. You have the protocol header checksum for error detection, the total length of the packet. Version, this is going to tell you, is it using IPv4? Is it using IPv6? Time to live, this is used by routers to determine each time a packet hops a router, the time to live gets decremented by 1, and this will determine if a packet gets dropped at some point. All these different fields that allow for packets to communicate all the various information, and I guess you can call it like metadata, right? So first thing we'll do is set a time to live. So we're going to set a time to live value of 10. So we'll say IP equals IP in caps TTL equals 10. And if we type out IP, we're basically saying, let's take a look at this IP packet that we're working on. Okay, so pretty much only thing that we've generated here is a time to live value. Now we can also let's look at the current destination IP of this. So that's currently set to the local host. You probably recognize this as the local loopback IP 127.0.0.1. And we could see that the source is also set to that as well. So we need to change that. So we can say ip.dst equals, and then in quotes, 192.168.9.1. And so that is going to be the IP of the default gateway. Okay, and then if we run IP again, you'll see that that's been updated. Along, it's sitting there with the time to live value that we set. And now we can change the source to be the Kali machine, the 9.2 host. Run IP again. You see how it just keeps getting updated as we add these values in. Now, let's say if we wanted to delete something, we want to remove that time to live value. We didn't want it to be 10 anymore. We could delete ip.ttl, verify by running IP again, and now we have no TTL value. It is just the source and destination IPs. Okay, we can modify the time to live to the RFC value of 64. Okay. And we can add TCP on top of this IP packet. So we're going to tell it, okay, we want to use TCP rather than UDP. Okay, so we've set that. And then we can add some more information to the TCP protocol. So this is where, this is layer 4 of the OSI layer model. This is where your ports are communicating. So we're going to be looking at source port and destination port. So S port, D port. So we'll say TCP equals capital TCP. S port, source port equals 1025. The destination port is going to be 80. Okay. Now we can run TCP/IP.show. And we have a lot more information here now. We can see the TCP protocol fields here. So this is going to be layer 4, the transport layer. And then we have the IP fields here, which IP resides on layer 3, the network layer. This is where logical addressing, like IP addresses, happen. And we could also add an Ethernet layer. Whoops. Oh yeah, not supposed to type out Ethernet total, just Ether. There we go. All right, so we've created that packet. Let's see, let's leave the terminal open. And now we are going to open Wireshark to do a little packet sniffing as we send out a packet. So we'll go to File, Open Terminal. So it's opening a new terminal. Let's just use this to type in Wireshark to go ahead and launch that. I'll minimize this terminal. All right, so we essentially want to select our network adapter, ETH0, and then start. So right now, you see nothing's happening, no packets are moving back and forth. So I'm going to go and minimize this. We'll come back to it in a moment. All right, so we will generate a single ICMP packet to be sent to the OWASP machine. Okay, so remember the OWASP machine is down here at the .12 host. We're at the Kali machine here. So we will say packet equals SR1 IP. Destination is 192. Whoops, forgot the quotes. 192.168.68.12. This is an ICMP packet followed by, I believe it's 12 X's. Okay. So we see here finished to send 1 packets, received 2 packets, got 1 answer. So remember at the beginning, I mentioned how Scapy is used to send packets, but then also get answers back. So we'll take a look at that in a second, but let's first move over to Wireshark. And we could see both of the ICMP packets here. So we can see how that it's sent from the Kali machine, which is under source. That's the .2 host. The destination was the .12 BWA machine. The BWA machine replied. So this is essentially the same as doing a ping, right? From the Kali machine, we say ping 192.168.68.12, and then we get a ping reply, an echo reply back from the BWA machine. And now if we type in packet, we see this is the answer. So, and you could tell it's the answer because the source is the BWA machine. Destination is our Kali machine here. So this is, like I said in the beginning of the video, this could be a quick and simple way to get an answer from a particular packet that you wish to send. Maybe you don't want to actually open Wireshark and like run the command and then look at it in here. This is an option to take a quick look. All right, and now we could change this up a little bit. Tell it to initiate a simple SYN scan. So instead of an ICMP request, I'm going to actually press up and pull this command from history because a lot of it is the same up to this point here. Okay, so I'm going to say TCP destination port is 80 and the flags equals S for SYN. All right, so once again, received 2 packets, got 1 answers. So there is an answer waiting for us. But let's take a look over here. Now we do see some ARP requests here. This is natural. It's attempting to get the MAC address since this is the first time that these systems are communicating since this VM instance was powered up. But what we're looking at here is the TCP requests. Or so this is the first SYN request here from the Kali machine. This is the response from the BWA machine. And if we type packet, we see the answer from the BWA machine. So this is essentially the same thing as looking at this right here. So you get the same type of information, but just in the Scapy command line tool. All right, and that is the end of the lab, short and sweet. Once again, we covered the Ethical Hacking Lab series, packet crafting with Scapy. All right, thanks a lot for watching.